Hello again. This is day 10, unit 3, which is chapter 4. And this is basically just a review of radicals, of just some properties of them and how we can simplify them, essentially. I'm going to say that it's a good idea right now. Okay, just a few examples. It's a good idea right now to write down all your perfect squares. You know, we don't have to bother with 1, but 4 is a perfect square. 9, 16, 25, 36, 49. And recall that a perfect square is just all of the squares. So this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. And we could keep going, but we're not going to end up using all of them. So the reason why I'm saying that we want to write them down, or you don't have to, but we're always going to be looking for one of these numbers. And you'll see why. So if I had square root of 50, there's a couple things I could do. I know, kind of like when we had the lesson on imaginary numbers recently, that I could rewrite this as the product of two radicals. I could say that, hey, this is like square root of 5 times square root of 10. That's true, because I could multiply these together and get what I started with. But this doesn't do us any good. I can't take the square root of 5 and I can't take the square root of 10. So notice neither of these numbers are in my list. Are there any numbers in my list that 50 is divisible by? Or that are any numbers in the list a product of itself and some other number to get 50? Yeah, 25. 25 multiplies with 2 to get 50. So instead of these guys, I could say, I'll do that right down here because I'm going to go back to this in a second. I'm going to say that 50 is really just the square root of 25 times the square root of 2. Again, I can say that because 25, square root of 25 times square root of 2 is square root of 50. That's good. The reason why I want to do this is because square root of 25, ta-da, you can take the square root of it because it's a perfect square. 25 is just 5 squared. And then you're square rooting it so the squares cancel, or just square root of 25 is 5. So this is 5, and then square root of 2 is stuck. You can't do anything with it, but it will stay inside of its bracket and just be lonely, but together with the 5. So square root of 25 times square root of 2 is really just 5 squared to 2, and that's how we simplify. You're always trying to split up the number into the multiplication of two numbers. One of them should be in this list. It has to be, otherwise you messed up. There is another, and I usually don't stress this very much, but some people can get here in their way of thinking, and that's okay. I chose to do 5 and 10 early on, just trying to show you that that's a bad example. Don't do it that way. Try and find a perfect square. It's very fast that way. However, you can do something called prime factorization. It just means keep on splitting things up until they're all primes. So the -5 is a prime. I can't do anything with that. But 10 I could split up. 10 I could say, well, 10 could be really the multiplication of 5 and 2. So I have this square root of 5 still from that. And 10 now could be 5 and 2. So square root of 5 times square root of 2. And now they're all primes. They're all prime numbers. They're not. None of these are divisible by anything other than itself and 1. At this point, I see that I have two 5s. So this could be written as, square root of 5 squared. And if that's the case, I mean, square root and a square cancel each other out. Bam. And I still have a square root of 2, square root of 2. So I get 5, not with anything, and then times square root of 2, which is the exact answer. So you can do prime factorization. Sometimes it's a little bit more work because you have more numbers to write. You find the same number and then square it and then eliminate it with the square root. But it is a valid method as well. Okay, here's another example. B. It's the same number, except we got a negative. But fortunately, we're smart enough to know that I'll write it out and then show you what really we should jump to. But this is really, square root of 50 and square root of negative 1. Now it's not a negative, and I can mess with it. And then this is essentially the same problem as we had in part A, if we're just dealing with the square root of 50. But we have the square root of negative 1 here. We had to take that out, and this is I. So we're going to have I in our answer because it's a negative. And then, we're going to get the same answer. We just did 50, so now we have 50 again. So this is 5. Oops, that's an ugly 5. This is 5 square roots of 2. But we have an I there. And generally speaking, we don't want to put the I in the back of a radical, because sometimes it gets confusing about what's under the radical bar and what's not. I think it's pretty clear in this part. I didn't draw this line farther, but in general, we put the I in front of the radical that's not imaginary, but still behind the 5. So like 5I square roots 2. And so a lot of people, every year people freak out with imaginary numbers, but ultimately for our purposes, all I got to do is just like rewrite this thing as a positive and then put an I out front. That's all that happened. So this thing right here is the same as I square root 50, and then square root 50 turned into that. We just put the I out front. Okay, here's a couple more examples. I'll do just this negative 8 here. Negative, I can't take the square root of a negative, but if I say that if I take I can't take the square root of a negative 8, but if I take the negative away and I say, oh, it's really I square roots of 8, now I just got an I in my answer. Essentially, I changed it to positive and I took an I out. That's what we end up doing anyway. So now we're thinking of 8. We want to think of numbers that multiply to be 8 to try and break it down. We still have an I there, but 8 breaks into only 2 numbers multiply to be 8, other than 8 and 1, is 4 and 2. So we'll try that. So we'll try that. Square root of 4 times square root of 2. Because 4 times 2 is 8. Square root of 4 times square root of 2 is square root of 8. And fortunately, 4 is one of the, again, refer to our little list up here. 4 is a perfect square. So we lucked out. There were only 2 factors, and one of them was a perfect square. But we would have been hoping, we would have been looking primarily to take out a perfect one of the numbers that was in the list, a 4 in this case. So square root of 4 is 2, and square root of 2 is stuck being under there still, and we write the I right there, and so we get 2I root 2. Again, all we really did was took out an I, made it positive, and then 8 broke down into 4 and 2. 4 is a perfect square. That's how we get 2. This square root of 2 has to be stuck still in there. Nothing you can do about that. The reason why I skipped A in favor of B was because if we could do B, we could do A. It's the exact same thing. I don't have to take out an I. This number 3 is a good problem. Here's why. I'll write these numbers again quickly. 4, 9, 16, 25, 36, 49. I'm going to stop there. 49 is already over half of 72. So 49 is not going to be a factor. Even if I divided 72 by 2, like the smallest number I can divide it by, that's not 1. It's not. 49 is not a good guess. So we can start guessing some numbers here. The things that we know about 72. Well, we want to. What numbers multiply to be 72? There's a couple tricks of this. Like I can start at 4. Does 4 divide 72? Yeah, it does. I can't think about it offhand. 72 for, this is quick long division. 1, 32, okay. 8 times 32, okay, so 18. So 4 times 18 works. I'm not going to use that. I know it's not the best option, so I'm not going to do it. But 9 works. 9 times 8. And I personally am not going to use this either. Right now you should be like, well, what the heck? We did it. We can do it. The reason why I don't want to use 4 and 18 is because 18 has a perfect square in it. You know, this times this is 72, and this times this is 72. I don't want to use 4 and 18. 4 is a perfect square, but 18 is also, I can keep on breaking this down. Same thing with 9 and 8. 9 is a perfect square. That's great. But 8 can be broken down, as evidenced by the previous problem. So what that means when that happens, if you can keep on breaking down the other number that wasn't a perfect square, means you didn't find the largest perfect square that 72 is divisible by. So instead of starting at the bottom, if you're trying to figure out which perfect square multiplies to be, this number underneath the square root bar, start with the largest number you can. And that's why this is why I started this problem by stopping at 49. I didn't want to list out anything more than, I didn't want to list out 49 because 49 is over half of 72. It's not going to be divisible. So I don't even bother doing it. Obviously, the next one is 64. That's not going to be, you can kind of see 72 is not going to be divisible by 64 evenly, and you're going to get decimals. And so I have to stop at 36 because 49 is, too big. And then instead of starting at 4 and seeing, oh, does 4 divide 72? It does, that's great. We should start at the other end, the largest one that could work. So we'll start at 36. Is 72 divisible by 36? Yes, it is. So 36 times 2 is 72. So this is really, I could split 72 into 36 and 2. And then I have square root of 36 is 6. So right now I have 8 times 6 times square root of 2. And I do have to multiply these two numbers out front because they're just regular numbers. You cannot multiply numbers, a number outside of the square root bar through to a number inside the square root bar. You can't multiply 6 and 2 here because 2 is stuck. But these are just regular numbers. They can be multiplied. So we get 48 square root 2. So the square root of 72 part split up. It simplified to be 6 square roots of 2. It's just that we had an 8 out front already, so we had to multiply. One quick note. This was the last example, but one quick note. These would still work. It's just not as efficient because we have more work to do now. If I took out, if I said that the 72 is really, you'd still have like an 8 out here, but like if I took out a 4, 72 is really 4 times 18. Okay, that's good because 4 turns into a 2. We could take the square root of 4 and we get a 2. But 18 is made up of some things. 18 has a perfect square of 9 in it. It's divisible by 9. So this would really turn into square root of 9 and square root of 2. But square root of 9 is really 3. So, okay, now we have 3. So we've gotten rid of a lot of square roots here. And we turned the square root of 4 into a 2 and the square root of 9 into a 3. So at this point, we'd have 8 times 2 times 3 times square root of 2, which, if you multiply these three numbers, 8 times 2 is 16. 16 times 3 is 48. So this would give you 48 square root of 2. Again, it's just a lot more. You have to keep doing the process over and over again if you don't choose the largest perfect square first. And just for sake of completeness and to beat a dead horse, if we said 72 was square root of 9 and square root of 8, I still have this 8 out front, by the way. If we split it up into these two, it's okay because 9 is a perfect square. So this thing now is a 3. And I can multiply 8 times 3, but I'm not done. Square root of 8, as we learned, can be broken up. It is really a 4 and a 2. So this is really like a square root of 4 and a square root of 2. So right now we have, well, and square root of 4 is 2. So we'd have 8 times 3 times 2 times square root of 2. And as we see, 8 times 3 is 24. 24 times 2 is 48. So we still end up with 48 square root of 2. So I don't want to scare you away from picking a number and the satisfaction of finding the right number that divides it, that's a perfect square. But it's just, there is a note about efficiency. If you start with the larger numbers to test those out, you'll have less work in the long run. Because if I chose 36 right away, bam, I'm at the end. I do one split basically, take the root and then multiply. And all these other ones I had to do 2 iterations of it. All right, well, hopefully this is familiar. This should be review. You should have had this in a few classes. All right. Best of luck.